So I hope that it is audible to everyone. Yes. Okay. So let us continue from where we had left off. We were doing some questions on this rolling motion, right? Yeah. Let's continue from there. So suppose that we have over here an object, right? And it is rolling on the ground itself. Right? The velocity of the center is nothing but v. So, fine. And you have to find out what is the velocity at this particular point P over here. Right? And the location of point P is such that it is on the periphery and it is making an angle of theta over here. The radial direction is inclined at theta to the horizontal. Right? So therefore, uh, how do you find this? So again, we'll start with the basic idea that the velocity of the point P is nothing but a vector sum of with respect to the center its velocity plus the center's velocity. Now, with respect to the center, the velocity direction of P is nothing but at 90 degrees this way, and it is nothing but having a magnitude of r omega. So this is omega over here, and it is given to us that this object is in rolling motion itself. So therefore, over here, if this is r omega, you add to that the velocity of the center, which is this way, be this way, right? Okay. So therefore, now let's do the vector sum. And we know that since it is in rolling motion, therefore over here for no slip, this r omega must be also equal to v. Right? So it means that at that p point you have v this way, and you also have v this way, and the angle between these two we want to find out, so that we can do the sum of these two vectors. So we notice that if this angle is theta, can we say that this angle over here is also theta? This is the radial direction, and this is the tangent over here, and this total angle must be 90, which means this angle is 90 minus theta. So therefore, the resultant velocity is nothing but equal to a square plus b square plus 2ab into cos of 90 minus theta, which is sine theta. You can pull out the v outside. It will be 2 plus 2 cos of 90 minus theta. How much is that? Sine of theta. That's all. So this is nothing but the speed of that p point over here. Okay. We'll also make few important note points. We notice that if the object is in rolling motion, the topmost point over here would have a velocity which is r omega, which is v only, plus another v, which means it is 2v. Fine. You can check that by taking the value of theta as equal to how many degrees? 90 degrees, right? If you set the value of this one as 90, you should get the velocity of this particular point, right? Which is v root of 2 plus 2, which is root 4, which means it is 2v, right? When the theta is 90 degrees, topmost point over here. And if you also look at this expression that we have derived, the maximum value of Vp is when sine theta is 1. Fine, over here. Which means that the topmost point has the maximum value of speed among any point of the rigid body. Fine. So therefore, now let's go to some other point over here. Maybe this one. Again, this angle that the radial line makes with the direction of velocity of the center is 180 degrees. And by setting the value of theta as 180, you can find out the velocity of the C Just name this as D point. So Vd becomes V root of 2 plus 2 sine of theta. Theta here is 180 for the D point. Sine of 180 is how much? 0, which means it is V root of 2. The other way of observing is that with respect to the center, the D will have R omega this way, which is V this way, plus the velocity of the center this way. So therefore, the resultant would be V root 2 at 45 degrees to the horizontal this way. Fine. And similarly, you can estimate the velocity of this point over here, R omega this way, which is V this way, plus the V this way towards the horizontal. And in this direction, we'll have V root of 2. Fine. And the bottom point has a velocity of anyway 0 itself. Fine. Okay. So these were some important points on this rolling motion. All right. So now let's let's move on to the radius of gyration. Sorry, not gyration. Radius of curvature. Fine. Okay. So the radius of curvature ROC, we can always find out the radius of curvature in two ways. What is the radius of curvature? Any particle which is moving over here on this path, or even if it is not moving, this path over here at this location can be of a circle. Fine. And finding out the radius of this particular part of the curve is known as the radius of curvature. Fine. Okay, how do you find out? Basically, you would say that there are two ways. One is there is a proof for this one. In circular motion, you would have studied. Otherwise, please wait for that video to be updated, uploaded. That the radius of curvature at any particular location is given as equal to 1 plus dy by dx whole square, entire thing power of 3 by 2 divided by d square y by dx square, its magnitude. This is one way. If you know the function over here, you can find out at this point by substituting the x and y coordinates at this location. After you differentiate twice, and finally putting the value of y and x, values of x over here, you can find the ROC. Fine. Okay, what is the other method? The other method is, if there is a curve over here and a particle is moving in that curve, the velocity will always be tangential to that path. Right? And there would be an acceleration of this particular object, right? That acceleration, it could be pointing in any direction. Maybe it is pointing this way. Fine. So this particular acceleration can be split into two parts. One, which is pointing towards the center of this circular path, which is nothing but the component of acceleration perpendicular to the velocity. And the other is along the velocity, right? Which is A, which is tangential, you can say. Right? And over here, the radius of curvature can be found out from this expression, that it is the square of the speed divided by the acceleration, which is perpendicular to the direction of velocity. This comes from the centripetal acceleration if the center is not moving. Right? Why? Because what is AC? v square divided by the radius. Actually more than that, but if the center is not moving, this is the expression. Fine. So therefore, let's take an example over here itself. Fine. For this object which is rolling over here, fine. Let's say that you have this object, fine. And the speed of the center is this much, and the radius over here is nothing but equal to r. And let's say that the only data given to you is the radius of this object. Fine. You're not given anything else. Fine. And you're asked to find out what is the radius of curvature of this point over here, the T point. Fine. Radius of curvature of this T point. Fine. Fine. Okay, so how do you do this? First, we need let's take this approach over here instead of the function approach. We need the square of the speed of that T point. Now we know that if this object over here is in which motion, it is given to you that it is in rolling motion. That means the topmost point will have a velocity of, with respect to the center, plus the center, which means it is 2v. Okay? And we also notice that the acceleration of this point, the T point, can be written as acceleration of T with respect to the center plus the acceleration of the center. We will assume that the speed of the center of the mass is a constant value, which means that the acceleration of the center is zero itself. There is no increase or decrease in the velocity of the center. So center's acceleration is zero. This part is gone. Right? So the acceleration of T relative to the center, if you observe the T point with respect to center, it's moving in a circular path, right, relative to the center. The acceleration is nothing but this way, which is the centripetal acceleration. So therefore, you can write that acceleration of the T point is, if the angular velocity is omega, then you can always write that it is r omega square in minus 2. Right? That's all, our job is done. We notice that AT itself is at 90 degrees to the velocity. So the radius of curvature can be written as square of the speed divided by the component of acceleration, which is perpendicular, which is, oh my god, I didn't write r omega. Please write that. R omega square, right? Why? That's the centripetal acceleration. And over here we can write that ROC is nothing but 2v the whole square divided by r omega square. But what is the value of omega for a rolling object? Is it not such that v is equal to r omega? Yes. Let's substitute that over here. So we can write the square of omega, which is the square of v by r. So therefore, on simplifying, we get the ROC as how much? 4v square divided by v square, and r by r square is by r, which means it is 4 times of r. Fine. This part is clear, no doubts there, yes? Now, you may argue over here that why can't we write the AC as uh, v square by r? Wouldn't this also be correct? Or why can't we write the AC as equal to 2v whole square divided by r? Can't this be correct? So which of these is correct? The centripetal acceleration is is nothing but v relative square divided by the value of this distance between the center and that particle, and that too in a direction perpendicular to the line joining. This is the actual definition of the centripetal acceleration. V relative square divided by r over here is the distance between the center and the particle's location. This is your quantity. If you, instead of r omega square, if you were to write it this way, let's check whether we get this value or not. What is the v relative between the top and the center? The relative speed. 2v to the right side minus of the velocity of the center to the right side, square of this one, divided by what is the distance between the center and that point? R. Yes, this is the correct one. V square by R. Fine. So therefore, if you use this expression, then also it will work out. You should get the same result over here. Fine. This part is clear, no doubt further. Yes. Yes. All right. Okay. So now let's end the class with this one. We'll continue in the next session. Fine.